Welcome, everybody. I'm Mark Sykes, Director of Planetary Science Institute, and here to talk about one of my favorite subjects, RNA and the Decadal. And this talk is going to be reprised on September 16th. A bunch of LPL people were unable to make it at this time slot, and so they've invited me to do it again. So we'll get started here. So I'd like to start off by talking about the importance of basic science and data analysis to NASA planetary exploration. And it goes, let's see, can I get this? Great. Excellent. I was just moving all the people around. You know, I have a quote from some quotes from this 1998 Academy report on research and data analysis. And, you know, they point out that under the NASA charter, that the first objective of NASA's, you know, the aeronautical and space activities of the United States is to expand human knowledge of the Earth and the phenomenon in the atmosphere and space, which provide the rationale for most of NASA scientific research. And the Academy points out in this report that you know, missions is one way that this objective is met. It's certainly the high-profile thing and consumes the majority of the agency's attention and resources. But that equally important components, but ones that are generally less visible and less appreciated, are the programs in research and analysis and in data analysis.
Full course meal over here.
Somebody needs to mute. Alex, you gotta mute.
Sorry.
No problem. And then also these programs, they provide the scientific underpinnings and the enabling technology for NASA missions, and the data analysis part of it turns the data into scientific understanding. So this is in an Academy report from more than a couple of decades ago. There's actually a lot of Academy reports on this kind of topic. I have to get back here to advance my slide. But I'd like to start off by pointing out that NASA planetary science is fundamentally different from astrophysics, earth science, and heliophysics. You know, first of all, astronomy has been around for a very long time and is deeply embedded in universities. And NASA astrophysics sits on top of a huge pre-existing investment going back over, you know, centuries in ground-based facilities, laboratories, and a massive astronomical community, primarily centered at universities. Earth science, you know, likewise, has been studied. You know, the Earth has been studied for a very long time. That there's a lot of deep well, today, corporate interests in geology and weather studies and ocean studies, and so there's a lot of infrastructure built around that. And also, one kind of unique thing about Earth science is that, well, if you're observing something from space, you can go check it out, you know, on the Earth. So there's this ground truth thing that goes on. You can make a variety of independent measurements of things. And I like to say that, you know, the sun has been observed and worshipped since time immemorial. And so again, heliophysics, and also since the advent of the space age and communication satellites, then space weather and the space environment is very important to that huge corporate presence out there, and modern infrastructure, and also with protecting life and society. And so NASA heliophysics sits on quite a major investment in understanding this stuff outside of NASA as well. And there's planetary. Modern planetary science was invented by NASA. Initially, we started out with planetary astronomy, telescope jockeys, and meteorite studies. And but then, you know, with NASA, was able to go to planetary targets, see them up close, interact with their surfaces and atmospheres. You know, this was a whole new game, and there's no large historical infrastructure to stand on. And so, yeah, in fact, I would say that the one thing that we can say with certainty is that when we go to a new place, wherever it is in the solar system, we're going to see stuff that we didn't expect, like, what the heck is that? What's going on there? This is something that I think is pretty common in modern planetary science, which is not quite as extreme as in other areas. So NASA has needed to create almost from scratch the scientific context in which we base our, do our basic research and mission data analysis to determine what we should be doing out there. What's the next question? Where should we go next? Initially, back in the days of Voyager, it was pretty easy. We go out there and say, what's there? We take a look. It'd be because we've never seen these places up close. So we have our grand tours that lays the context. Today, the science that we do is far more complex. I mean, my God, we're blasting laser beams at rocks on the surface of Mars and examining the light that gives off to determine their composition, and we're doing chemistry on the surface of these places. The complexity and detail of the science we do today is far greater than when I came to the University of Arizona back in '81 as a telescope jockey. So NASA Planetary Science. Oh, and there's no big corporate interest in this stuff. There's no industrial underpinnings of this where that's comparable to certainly Earth science. There isn't the pre-existing community and database of facilities with astronomy and such. So NASA Planetary is the only outfit that's really kind of, NSF, but to a much smaller extent, but it's the overwhelming source of funding for doing what we do and integrating our mission data into our basic sciences to understand what it is that we're looking at out there. And in our solar system and in other solar systems, because I would consider that to be planetary science too, but that's me. And also questions that we're now asking about where life could arise, in the solar system and elsewhere. This has been a NASA show, and so NASA is just about the sole source for supporting it. Oh, and just as a side note, I want to say that planetary science mission teams play a critical role, not just ensuring that the primary goals of the missions are achieved, the primary science goals of the missions received, but because we're going places where we're always going to be surprised by what we see and have to deal with the unexpected, we need a science team in place in real time to accommodate the unexpected. Saw this a lot on the Dawn mission, where it's like, my gosh, we have these cryovolcanic structures. We need to make sure that we're going to be making good observations of these things. It's not something that we either predicted when we wrote the proposal for Dawn or when we launched. We had a baseline operation plan, and we had to make modifications to that to accommodate the science that we were discovering in real time. And then sometimes you have to do, if something doesn't work well, workarounds for that. The research and analysis programs are no substitute for a well-staffed and well-funded planetary mission science team. We want to continue analyzing the data on into the future, but we need people that are well-supported, well-funded, and well-staffed on the scene, if you will, on our planetary missions. So what is RNA? So let's see, our RNA, including laboratory and spacecraft data analysis programs. Oh yeah, they've had a long history in NASA going back to at least the 70s, providing a means of providing grants to scientists in academia, JPL, nascent private sector entities like PSI and others. PSI was established in 1972 and was getting some planetary astronomy grants, was also working on Mars missions, the early Mars missions. to build up not just the knowledge base, but also to build up the community of people capable of integrating all this stuff and determining what we're going to do next. And now I include in here some of the instrument stuff. And these were grants, and there's in the 1980s we started to get interested in designing mission instruments, and so we had PIDIP, the Planetary Instrument Design and Development Program. So RNA has a very long history, the agency, and in 2017, I thought there was a nice summary of the range of stuff that these programs do. There was another Academy panel that Planetary RNA supports a broad range of planetary science activities, including analyzing data from the past and current spacecraft, laboratory research, theoretical modeling, computational studies, geological astrobiology, field work in planetary analog environments on Earth, geological mapping, analysis of Earth and space from Earth and space-based telescopes, development of flight instruments and technology, and the primary role of the Planetary Science Division RNA programs is to address NASA's strategic objective for planetary science and PSD's science goals. And they actually have science goals, yes. And this, and this is something I've brought up in the past, that there was a midterm decadal review panel where NASA Planetary Division was asked to say how well they complied with the decadal recommendations for funding. And they came out with one plot, which was the one on the top. And it was challenged. They came back with another plot, and then ultimately came back with a third plot, which indicate that there really is, from the perspective of the Planetary Science Division, the definition, if you will, was kind of fluid. And so that was problematic, and is the basis for my calling on the Decadal Survey to actually define, if they're going to put in RNA recommendations, they need to define what they're talking about. So my proposed definition is simple, and it conforms with what's been said in previous Academy studies. That research and analysis programs fund openly competed proposals for basic research and mission data analysis, but, and I say this needs to be explicit, it doesn't include mission development, science team support, that's mission stuff. In the last decadal, they split off instrumentation and technology development. They made a separate recommendation of that. And so I would exclude that from the RNA because it's two separate recommendations. The last time they said it should be 6 to 8% of the Planetary Science Division mission budget. And also I would exclude research internally funded by the agency, such as internal scientist funding model, this SARA program, because these are not openly competed programs. And so where is RNA in the NASA Planetary Science Division budget? I'm going to show you. It's all over the place, and that's really okay. This stuff is posted online. Okay, I'm going to stop sharing this. I'm going to start sharing. Let's see, where the heck do I share? Share. And here we go. Okay, so here is for 2017 to 2020, a complete breakdown of the Planetary Science Division budget as obtained through the Freedom of Information Act. And you'll see that there's discovery, new frontiers, Mars exploration, outer planets and ocean worlds, planetary science research, planetary defense, lunar discovery, and technology. And what I've done is I've taken the definition I gave, and you can, there's flexibility in how you interpret it. For instance, in this case, I have allowed planetary science or participating scientist programs on missions to be considered RNA. You can decide, nah, if they're too much of mission support, as opposed to independent research that's associated in a mission going on in real time, one could say, oh, we take that off. But you could take the definition and make a justification for each line in this budget. And so you see the yellow are the RNA things as I've defined it previously. And under the discovery research, there's a bunch of programs that fall in. And then there's some that I wouldn't include, like Laddie Science Team. And again, I would say that you've got the numbers, you could apply things and see how it all works out. There's Dragonfly, that's not an RNA, that's a mission. No, but there's data analysis programs here. And OSIRIS-REx PSP, so we'll include that as well. Mars exploration, Mars research and analysis. And there's several data analysis programs there. I also include these participating science programs. Over here, though, they don't have budgets in recent years because they're past missions. Outer planets, same thing. Outer planets research, number of programs there. Now, here we go, planetary science research. So this should be getting into it, right? But there's things in here which aren't planetary science research, like the Rosetta mission, planetary data system, which is where missions, stash their data and working real time to do that. But here's planetary science research and analysis. So you'd think, well, gee, there's a place where all or a lot of the research programs could be, but there's things in here that are not research programs, like travel for the people at headquarters, program management, detailees, the people that run Inspires. I think that's the NRES contract. I think they do that. Venus activities. But then here are programs that we recognize. Planetary geology and geophysics, which doesn't appear in the roses anymore, but is still book kept here, and even had funds assigned to it in 2020. Cosmochemistry finally went away after being merged into solar system workings. So we have things that we recognize. NEOWISE, that's a mission. I didn't include instrument development programs because that's a separate decadal call now. And Venus Express, no money there, but it's a mission. And Picasso, it's an instrument program, so not included. A bunch of programs here. So they're like I said, all over the place. Here's the Eternal Scientist funding model, the science enabling research activities at NASA centers. They're not openly competed, so I don't include them here. Perfectly fine to have in the planetary budget. I just think it makes no sense to include them as RNA and to include it in any kind of a, because they're going to be scoped basically by the needs of centers, and that's, I think, beyond the scope of the Decadal Survey. Now it's interesting that one thing that I learned while doing this was that here's Survey, and the former NASA Lunar Science Institute. It's got no budget here. Well, it did previously, $10 million a year in 15 and 16, but that's because survey tasks are distributed among other programs, or so it's not grouped together under a single survey budget line, at least in the what's been provided by NASA. Now I should say that, okay, well, I'll continue on here. So there's lunar programs, not much right now in terms of funding, and technology, which I don't include. Now, what I did was I went into the federal budget and I added up all these numbers and was able to tie everything out to planetary science, the discovery program, everything as it appeared in the planetary budget, which goes down to about the level of like discovery research. It doesn't give all this stuff in there. This is in the president's budget request to Congress. They all tied up very close. So that means that we've got all the numbers in this table. And so, but there's a bunch of programs that don't appear. And that's because they're accounted for within some of those lines, up above. Now, if now you look at something like near Earth object observations, $77 million in 2020, and I know that there is some RNA stuff in there, because there's some planetary astronomy type competed ground-based observations, which appears in the roses that people get funding for. But there's also facility support. There's probably some mission development and stuff like that. And so, if NASA wanted to provide this information, they could also provide some greater granularity if they wanted. So anyway, so these numbers are the basis of the plots and stuff that I'm making, and they're all available online at planetarypolicy.org. So you can make different assumptions. You can reproduce what I'm doing. You can make different assumptions and see how those numbers work out. It's all open for everybody. And okay, so I'm going to go back to my presentation. See, I gotta stop sharing this. And if you want to break in with a question, feel free, because I know that I'm used to looking at this stuff, so it all makes sense to me, but maybe I'm not very clear about something.
Did you calculate out the curves similar to, calculate your own curves and then compare them to the stuff that you were getting from NASA?
Well, the stuff that I got from NASA is the basis for everything. I can't calculate curves without the numbers, and the budget numbers all come from NASA. And so, through the FOIA. Oh, and I was going to say that there are different colors of like red and green and stuff like that. Those are from different FOIA requests. Let me get my talk back on. Does that make sense, Liz?
Yeah, well, you showed the 3 different curves because they didn't have a good,
Oh, that was the from the here, let me go back to my talk here. Oh. The 3 different curves, those were from the presentations given at the midterm Decadal review. The numbers given there, and then I plotted them up here, and I separately calculated the thin lines, which are the and I'll be posting this presentation so you can look at it. This information is also on the planetarypolicy.org site. The thin lines, which is the Decadal recommendation, because it all bases on whatever the 2011 number is. The Decadal said, hey, 2013 has got to be 5% above the 2011 number. In the initial presentations given by NASA, they either had a line or had some numbers, but they didn't include the Decadal recommendation was increasing 1.5% over inflation each year thereafter, and they forgot to include the inflation. So it's just 1.5%. So they're where this line appeared on their presentation was down a little bit. But yeah, this is all from the midterm Decadal review panel presentations, which is on the Academy site. Okay, yeah, so here's the URL for Planetary Policy. All my spreadsheets are there. Everybody is absolutely welcome to play with them and send me email if there's any questions about whatever I say there. But it provides all the information you need to both reproduce my numbers and, like I said, to make your own assumptions and definitions and see how it plays out. So, okay, so the next thing is what funding levels have been recommended for by Decadal Surveys for planetary RNA. So I went back actually to the very first Decadal Survey, New Frontiers. And it was really very interesting. I guess I didn't pay that much attention. I thought, oh, this sounds good, but I didn't think any more of it about it after it. It talks about the survey recommends an increase over the decade in the funding for fundamental research and analysis programs at a rate above inflation that parallels the increase in the number of missions, amount of data, and diversity of objects studied. So it recognized that as we expand our exploration of the solar system as we are looking at more objects, they're sending out more spacecraft, that there's more homework we need to do, both in terms of preparing and deciding what we want to do, what makes sense to do next, what are the ripe issues. We got more data to analyze, and these things just don't like drop off, you know, when they're done, once the press release is out. And I'll talk about the recommendation. And so what they came up with was the overall funding for RNA programs climbed in recent years to approximately 20% of the overall flight mission budget. And that recently it's closer to 25%. And we kind of like that. So we believe this is an appropriate allocation of resources, that RNA should be at the 25 of flight mission projects. So I thought, okay, well, that's interesting. And then, so I went and I took the flight missions. And again, what do you include in that? Do you include the multi-mission operation stuff? Do you include just the line for the mission, you know, like the OSIRIS-REx? And so using that table that I showed before, I went and added up all those things, and you know, that's of course the vast majority of the Planetary Science Division budget. I divided it by 4, and I get between $517 and $599 million as from the first survey, what they would recommend today, following their formula. Again, you know, you can make different assumptions, come up with some different numbers, but it's all there. Now, I haven't gone back to check for the period from 2003 to 2012 because I don't have that. I have information on RNA programs back to 2009, but not all the other stuff, not all the mission budgets and stuff like that. And I don't know if they survived the transfer from the previous accounting system, RATS, to the current one, Raptor. And you know, I don't know how far back things go there. And maybe that would be an interesting thing to do for historical purposes sometime. Let's see here. Oh, but one thing I would note is that, and I did a little overcorrection here, that the first decadal, they included instrumentation stuff in RNA. And so when I look at the current budget and I add up all the technology development programs, though I exclude plutonium production, average over the past 3 years, we got 103 million. And so if you were to deduct that from the 517 to 519, you get 414 to 496. But actually back at the time, again, the first decadal was talking about programs that were grant programs. And so at that time there was only PIDIP. And so if we were to just consider the grant program, so like Picasso, Matisse today, this wouldn't be 103, it'd be much smaller. And so that would bump up these numbers a lot closer to the 517 to 599 from the first decadal. So just an interesting metric, and it's something to think about as we go forward here. In the last Division and Voyages survey, they said, okay, starting in fiscal 2013, increases at 5% over fiscal 2011, and then increase by 1.5% above inflation each year thereafter. And so applying it to the programs that I've yellowed out on that previous page, that gets you starting out in 13 at 183 to about 231 in FY20. So about half of what the first decadal would have by their metric. But one thing I would note, in terms of the importance that the second decadal applied to the research and analysis programs, and this was a question I brought up after the first decadal survey. Well, I'll come back to that. It says, if you don't have enough money to do all the recommendations, then what do you do? So The first approach is to be descoping or delaying flagship missions. After that, that doesn't do it, then you change funding available to New Frontiers or Discovery programs. And only if adjustments to flagship missions can't be the problem. And high priority should be placed on preserving funding for research and analysis programs and for technology development. Now, this is, in terms of the importance of this was to the Decadal Survey in 2000, gosh, I think it was 6. I did a survey, conducted a survey of the planetary community because putting that question to them, that's saying that, hey, you know, the Decadal came out with all these great recommendations. What if there's not enough money? What comes first? And so the choices were flagship missions, New Frontier missions, Discovery missions, or RNA programs. And you couldn't go 1, 1, 1, 1. You had to go 1, 2, 3, 4 in whatever order. For every person that took the survey, they were the order of those things were randomly done. And there were some other questions, and there were boxes where people could fill in whatever their comments were. The thing went viral, and about half of the planetary community actually responded to it. And but the interesting thing was that within about 6 hours, with several hundred responses, the statistics of the answers settled out, and didn't really change after that in terms of what things were priorities and by what amount, which was kind of interesting from a polling, science perspective. And the result was very clearly the #1 priority for people was that the RNA program should be preserved. The second priority was discovery. The third priority was New Frontiers, and the fourth priority was flagships. And it was interesting because I got to watch in real time as people were trying to skew the results. I saw one thing saying, New Frontiers got to be #1. Everybody pick #1 for New Frontiers. And so I'd see like a little bump, going up in the New Frontiers thing, but the response was so large, over 1,000 people responded, and by reverse IP, I could check to see that, yeah, they're the NASA centers, they're universities and stuff, that just washed out all those efforts to try to skew the results. So this finding by the Voyages and Visions, the last Decadal Survey, is consistent with that survey.
Mark, I'm having a little forest for the trees moment here with the 25% thing. So back in the day, the first Decadal Survey, they said that 25% of the NASA or these planetary science budget.
No, of the flight projects, flight missions.
Okay, so take that budget, divide by 4, and then that should be your RNA budget. So how close to that are we? I guess that so one slide said
not close.
Okay, are we at the?
I'll get to where we are. It was about twice. It was about twice the level recommended in the second survey, if you were to apply it to today.
Yeah, I mean, I see these numbers, and in front of me are half of the ones before.
Right.
And these are current. So in FY13, it was 183 million. Anyway.
Oh, no, that was the recommendation.
Right. So what did the flight end up and all that? So that's what I'm looking for.
Yeah. We can go back to that, but yeah, the flight divided by 4, average over the last 3 years, you get somewhere between 517 and 599.
Oh, okay, that was that number.
Yeah.
Okay.
So, to what extent has NASA complied with the recommendations from the last survey? So, taking the yellow things out from the budget that I showed there, the blue line is the Decadal recommendation, and the black line below is what's been going on, which is not good. Making my assumptions, and like I said, you can go in and pick whatever you want in there and make different assumptions. But this is what I get, which is that It's done a very poor job of following the Decadal recommendation. And I would also like to point out something of a historical interesting thing. See this divot here? In 2010, there was a big effort by the Planetary Science Division, and this is before anybody who's there now was there, before Lori, before Steve. There was a big effort to rephase as many grants as possible. Jim Green was saying that Congress had said that NASA needed to spend out all the money that was appropriated for it that year. And I was on the Planetary Science Subcommittee at the time and said, nah, you know, Congress didn't say that. They said NASA needs to improve its accrual of costs and outlays. And if you get a $60,000 grant on September 30th, the last day of the fiscal year, you don't have to spend the whole thing in that day. It's accrued, you know, done. Well, okay, so they told people, hey, you don't need your next allotment, like your year 2, year 3, right on the anniversary date. Let's shove that off until you know, the next fiscal year. And so they managed to, you see here, this is the result of the rephasing. So say things are about 175 million. So so they got about 25 million out of the research programs. And I had to ask Jim, I said, so Jim, you said you have to spend all this money, you know, this fiscal year. So what are you spending it on? It was an MSL cost overrun. And so it's like, okay. But then I pointed out that I hope that you're going to be adding, or I should say that you push these obligations off to the next fiscal year, you know, and maybe 2, but certainly next fiscal year. And the only money that's available to pay for these obligations, these rephased things, is money for new awards. And so you're adding the money back to these programs to cover these new obligations, right? Because otherwise it's going to kill selection rates. Oh yeah, we're adding it back. Well, as you see here, in 2011, it wasn't added back. And if you say a third of the new awards is about a third of the program, you know, 3-year awards, that's about $58 million. 25 billion is about 40% of that. Selection rates at the time were like 40%. And so you multiply that and you end up with 20%. This was the first year of 20% selection rates. And it was because of this effort to cover MSL cost overrun, and money was not put back in these programs. And then things have only declined since then. So interesting historical note. So the question is what should the decadal funding recommendation be for RNA? I think that the first decadal really got it right, just speaking in general, when they said that you need to increase it in a way that parallels the increase in number of missions, amount of data, delivery of object studies. However, one thing that Decadal survey missed was not that we're going to like asteroids and these planets and stuff like that, but now we're going to a whole different set of environments, you know, atmospheres, surfaces, different kinds of surfaces, icy, rocky, and it didn't take into account the sheer complexity and range of the kind of science that we're undertaking today and are going to be undertaking in the future. And so I include a little plot here from the PDS on their anticipated just data volumes to be archived in the near future. And you see that it blows up. So when you say, you know, mission complexity, I mean, the kind of instruments, the kind of measurements we're doing today, which are just amazing, in the sheer volume of data coming back, in part due to new communication technologies like the laser stuff, that again, it underscores the sentiment of the first survey of we need to be taking this stuff into consideration, unless our whole goal is to collect data and, you know, so that other countries can analyze it. So I'd say that we're in dire need of greatly expanding the RNA program to address the science objectives of our Planetary Science Division, and to provide the breadth and depth of basic science and data analysis needed to support our science missions. In addition to gaining something more than, you talk about level 1 requirements for mission. That's a minimum. And we need to be, we're putting a lot of money into these things. And frankly, I think that at some point, the taxpayers could come back and say, we should be getting more bang for our buck. And so we need to be doing more than the minimum science. And to do that, we need to have, well-funded mission science teams, but also we need to have a real vibrant RNA program. And so I would say that we should keep to the 25% of the flight mission budgets, including mission development. You may want to toss in, you can define it however you want. The target that I would propose starting in 2023 is $500 million, which is substantially more than is being funded today. But I would say it reflects the need that we have. And frankly, we don't have the number of scientists needed to do all the work that we should be doing, today. And we're not doing a lot of science, where there's lab stuff, some theoretical calculations, as well as data analysis that we should be doing. I would say that, so I would, just like the definition of RNA, you could tweak around what you include in the flight mission budget category. I would say tweak it around so you get about 500 million for 23, and and then use that as your guideline going forward. And I would say that if it continues to grow, 1.5 over inflation every year, but let's say flight missions go down, 1 year in between flagships or something like that. You don't cut the RNA programs. You may not increase the budget, for that next year or 2 or 3, but you keep it static. It's predictable. So you can throttle the growth. And then there's a question. Okay, well, that's a lot of money. Questions been raised. What are we going to cancel in order to pay for it? Well, you don't cancel anything. It's not a choice between RNA missions. We need to have these things work together in order to achieve NASA's planetary science goals. And so you don't choose between them, but you do need to send a budget to Congress that incorporates the Decadal recommendations. So if the Decadal actually says $500 million, then you send that budget to Congress for $500 million plus the cost of the other missions that you want to do and maintain and extend and all that stuff. And then it's up to people like us to go up to the Hill and advocate for these things. And I think that we could do a pretty good job. And I think that we could make this happen. And let's see, I make a note here about, so volatility. RNA programs, totally predictable. You don't have cost overruns. Discovery and new frontiers, you shouldn't have cost overruns because those are cost cap missions. And even if you have extended missions, that's all predictable. So the volatility in the budget is primarily in the flagship class missions. And so I would say that one of the things that maybe the Decadal should talk about is that when flagships get into trouble, and they always get into trouble, that NASA needs to go back to Congress and say, please, sir, can I have some more? And rather than engaging in the typical cannibalism that goes on, I sat on all the extended mission panels for senior reviews for extended missions, and chaired a couple of them. And I can't tell you how irritating it is that they made a great case, and they got, with the exception of a couple recommendations, not just for this baseline thing, and I don't know where the guideline budgets come from, but for augmentation. And then because of overruns with these new flagships, that for a lot of these things, that money was taken away. And it's like, what's going on here? So I think that we need to protect our research programs. We need to protect our competed cost cap missions. And, you know, if there's a problem managing flagship missions or developing them or something, and you need more money, JWST, then go to Congress. Don't, you know, chew off somebody's arm. And then how do we ensure NASA compliance with the RNA funding levels? Because they didn't do a good job last time. So how are we going to make it different? And we make it different by requiring, or at least recommending, that they be transparent. And so you saw that budget sheet I put up with all the yellow bars on it. I would say that it should be recommended that at the end of each year, or after the end of the year, when they close out the year, they put out a new chart or new spreadsheet that has all those budget numbers for everything in the Planetary Science Division, and then take the definition that the Decadal Survey comes up with, apply it to each element, say, yes, I'm gonna put yellow on that. No, no yellow. Yes, yellow on that. Add up all the budget numbers for the yellow programs over the course of that year, and then compare it with the Decadal recommendation. And so every year, NASA should be able to demonstrate its compliance or level of compliance with the Decadal recommendation. That's transparency. And all this stuff is accessible through FOIA, Freedom of Information Act. And so there's nothing secret about it. And in my March talk to the Decadal steering group, you know, I said that if NASA didn't want to do it, that I would stand up at the plate and say, I'll do it every year and generate the, you know, put out this stuff. And if I take after my mother's side of the family, that'll be for another 40 years. So anyway, so this is all doable. It's not complex. It's a little accounting, simple math. It's arithmetic. So also, what am I doing here? Okay. So why are these programs important to the planetary science community? So you know, one of the things, and you notice that I've been pushing this on the basis of strategic objective needs, you know, mission support needs, you know, mission analysis, return on taxpayer investment needs. I haven't say, well, you got to do this because we got low selection rates. Help us, please. Like, no, that's not the rationale for vastly increasing RNA. The rationale for increasing RNA are the reasons I was giving before. You know, there are the basis of NASA's objectives in science and also in defining and getting benefit from its missions. But it does have impact on the community. And that's what this slide is about. So earlier studies by the DPS indicated that more than half of the US planetary community relies on RNA funding for more than 50% of its funding, of their, actually it's more than 50% of their salaries. That's it. And so a shrinking RNA budget, which is what we have today, translates to a shrinking community at a time when the scope of science being undertaken by the NASA Planetary Science Division is greatly expanding. And so, yeah, so I would say that without the underpinning of a vibrant RNA program and planetary community, NASA cannot do its science job, which includes its missions. And that right now, under current NASA leadership, early career scientists, they don't have much to look forward to. In fact, I was talking to an early career scientist this morning, and he said, it's not that we have nothing to look forward to, it's like we can't get our early careers off the ground. We want to increase diversity, you know, grow our community. You can't do that when you have shrinking resources. And frankly, I don't think the taxpayers are getting the return on their investments. And well, there's some things we can talk about hiding costs from peer review panels. That's another topic altogether. So what can you do? You can make noise. You can provide input to the Decadal survey, and you can educate your delegations back in DC, because it's not all about bright, shiny objects. And I've been talking to people up on the Hill for a couple of decades, and they completely get, this is why, you know, back 20 years ago, Ed Weiler told me that I never get to ask any questions about this stuff when I go up to the Hill to testify, and you can't sell this to Congress. Well, I've been up on the Hill, and old Ed was starting to answer questions from Congress people that I wrote about these programs, and I even wrote report language in the federal budget, or the NASA budget, describing the importance of these things. This is stuff that it's not a hard sell. You just have to go do it. And I have found both Republicans and Democrats to be totally receptive to the idea of creating a vibrant community, laying the groundwork to get the best missions and to get the benefit from those missions. And when I've had meetings with some staffers back there, it's been funny where you have an appointment to meet with like one person and 8 people show up, because it's not political, both sides of the aisle. So that's why I'd say that, if the administration puts the Decadal recommendations into their budget request to Congress, we can make it happen. So my final summary thing is what we need from the Decadal survey. It needs to define RNA. It needs to include what is in it and what is not in it. Drew, you need to oh, you are mute. Somebody needs to mute. We need to, the Decadal needs to recommend a specific and substantially higher funding level and plan for growth that reflects our needs. And then we need, it also needs to recommend a specific means by which NASA is going to transparently demonstrate its compliance with the Decadal funding recommendations every year. And it's not hard. Okay, so that's the show. Any questions or whatever?
If no one else, slightly off topic, I was going to make a comment, but I was going to let everybody else go first.
Okay, well, people feel free to chime in. I don't think there's a raise. Well, there's probably raising hand, but I only see like a handful of things here. I don't know if that automatically pops up or something. So just unmute yourself and talk if you want.
Hey, Mark.
Yes, Michael.
Yeah, Michael, this is Michael Ayer. I put a question in the chat, but it actually is a bit, it is a bigger question. It's like, I just stumbled over, why did you include Astrobiology Institute as an openly completed RNA? But it leads to the further question, what is the strategy and information source to find out which lines are actually having RNA components?
Well, first of all, I'm not digging into whatever tasks are underneath some of these lines. This is the level of detail that the FOIA office told me that I could get, and so like I mentioned NEOO, that near Earth objects observations, that it's certainly out of the $70 million has a component that one would characterize as RNA. So if the Decadal said, okay, we want to fund here's the definition, here's the funding level, then when NASA goes to demonstrate its compliance or lack of compliance, whatever, with the funding recommendation, it could give all these things I provided in yellow, but then they could say, hey, and then under NEOO, this is broken down into these 3 tasks, of which near Earth object ground-based observations of NEOOs that appears in the roses is an RNA component. So we're going to add that budget into our sum of RNA things. So I would leave it to the agency to make the case of how it applies the definition that's provided by the Decadal to each thing. And if they want to, now I put in Astrobiology Institute because there's components of it that was competed. I was trying to be generous, but if NASA came back and said, we don't want to include Astrobiology Institute or whatever it is today, because I think Astrobiology Institute has been replaced by something else now. Then it could make the case that we're not including this, or we are including this. So I would leave it to NASA to decide how explicitly it wants to apply the definition and make the case for each thing it applies these things to. Again, it's not hard. Does that help?
Yeah, but I was just wondering, you had a reason to now do this yellowing and define the lines in yellow because NASA didn't do this specifically, or not?
Oh no,
correctly?
NASA's never done this. I mean,
Okay.
maybe they do it internally, but they haven't published anything like this, except for there were a couple of years when Jonathan Rawl gave out a list of information that it only had the RNA programs on it. So one could say that implicitly that, well, they were defining RNA when he handed out the list, and it's totally consistent with what I've marked out here.
Yeah, that would be a good information trail to follow up that actually did happen.
Well, but see, we leave it to NASA. I mean, if the Decadal says, hey, we want you to do this, we want you to show the budget for the agency, show all the program elements in that budget, and then identify those program elements that you say are compliant with our definition. And then that gives people the opportunity to say, well, why did you say this is consistent? And then, that can be a discussion. And,
Yeah.
but everybody's talking from the same plate. They'll have all the budget information, they'll have the definition applied by the Decadal, and they'll have NASA's application of that to things in the budget. And if people have questions about what they've done, well, now they can ask.
Yeah, but I guess we don't have much hope that this will be implemented soon. So that what would be then our next step to make sure that we understand which lines are RNA and which are not?
Well, again, this could be implemented in 2023.
Okay.
So that's pretty soon. I mean, it's 2021 now, getting to the end. But again, it's going to be in the hands of the Decadal. I mean, if you know people on the Decadal, we could say, I like this definition, or I think that you ought to tweak it that way. Ultimately, it's going to be up to the steering committee on the Decadal to actually articulate any definition that appears in the Decadal survey. So I'm hoping it'll be what I've written, but who knows?
Okay, thanks.
Mark, I had to step out there for a minute, but I just wanted to say I really liked your idea of going back and asking for more from Congress about flagships, but that doesn't have to be a like a servile, we screwed up or whatever. It's that can celebrate how.
If Congress will give you money for being servile, then I would do it.
Well, okay, but still, I mean, it's a reflection of the fact that those are the biggest ticket items. Those are the highest profile items. They sell pretty well, going to the surface of Mars, blasting of lasers, all that good stuff, building the biggest space telescope ever conceived of, that good stuff. Okay, and that, we're doing things that have never been done before. Sometimes some things cost more.
But Congress loves the Decadal. Congress likes the Decadal. They will often say, follow the recommendations of the Decadal. And so if the Decadal says it's important to do this and that, and well, then you got to do this and that. It's not just one thing. And the flagship recommendations of the Decadal, in the past, have just been what's the top recommendations 2, 3, 4 for that class of mission. And in the last Decadal, the Decadal stated what the priorities were. If you don't have enough money, you push off the flagship.
Well, right, but I mean that sometimes that works well, sometimes that doesn't. Jupiter goes away, or whatever your target kind of.
Oh, then you wouldn't have a Taurus to study.
No, I study it from the ground. That's an easy one. I put my eggs in that basket long ago. But the point is, sometimes it is expedient to meet your launch window, whatever, and
well, that's why you ask for more if you need.
Right. And those are the things. But yes, it would take somebody in the NASA leadership to shelter the hens, the small little eggs in the basket, and humbly offer up for sacrifice the large ones to say, look at what you'd miss if you didn't give us more money for this. And here's why we need the more money, because we're doing something new, you know.
Well, we could offer you on an altar, Jeff. We'll sacrifice this too.
Oh, it happens every time I write a proposal.
Yeah. No, I mean, there's always politics, you know, and so, you know, but you know, look at all the people that were pushing for Europa, and the result was that NASA's budget has gotten a lot, Planetary's budget has gotten a lot bigger.
Mhm.
They weren't saying, hey, only do this.
Right. No, I mean, hopefully this works, because boy, it is painful right now.
Do what you got to do.
Yeah. Thanks for your work.
Anybody else?
Yeah, Mark, there was a question in the chat earlier from Michael I.
Yeah,
why didn't?
he talked
Oh.
about that, about Astrobiology Institute.
Yeah, okay, sorry, I was distracted on a Zoom bomb.
Yeah. Okay, well, thank you all very much. Like I said, yeah, if you really want to hear it again, I'll be doing it, but it'll be through LPL, I think, Lunar and Planetary Lab at U of A. So thank you for coming.